Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shalim bin Baharudin, matric number CD230176. And next, I'm going to continue our presentation with case study real world application of refrigerator. For introduction to case study, the kind of compression, economic, and the quantity of interstage heat load that need to be compressed all influence the number of refrigeration level, which means the way for us to identify the number of refrigeration level all depends on the compression economics and the quantity of the interstage heat load that need to be compressed in that particular circle refrigeration system. And next, I'm going to briefly explain about the type of system that exists in refrigeration system. Okay, the first one is one-stage system, which is a typical one stage refrigeration system using pure propane as the refrigerant. Okay, this is the example of one-stage system, which only have one circle of system in the process. Okay, number two is a two-stage system. A two-stage refrigeration system and an interstage flash economizer typically result in saving by eliminating process heat at the interstage level as opposed to the low stage level. More saving can be made. This is the diagram for two-stage refrigeration system. It differ from the first one, as you can see here. This one have like two circulating system in while in the process of cooling. Okay, this is also improvisation for the first one, which focusing on saving more in terms of heat and energy and overhead costs. Number three, three-stage system. This is an even more efficient three-stage propane system. Similar to a two-stage technique, flash equalization and an intermediate heat can be employed. When comparing to a two-stage system to a one-stage system, the saving might not be as obvious, but they might still be sufficient to justify the additional equipment. Okay, referring to but if we compare the three-stage system to a one-stage system, we can see this is a lot more in terms of improvisation and also can produce a lot more saving during the cooling or refrigeration process. For the next slide, I'm going to explain about the application of refrigeration system in our daily life. Okay, for the first one is district cooling, providing chill air to urban and touristic area to preserve comfortable enclosed space independent of the outside weather is one of the largest cooling market. District cooling systems are commonly employed in district region, major hotels, and resort to provide refrigeration production. The district cooling is a huge refrigeration system that are used to chill down the outside weather, especially in the touristic area, so that the people there will be more comfortable even on the outside of building. Okay, number two is electricity production. Often, the process of producing electricity begins with the combustion of different fuels. To maximize efficiency, there are several requirements that must be met by the inlet air. The incoming air density decreased due to the excessive heat, which reduced the amount of electricity generated. This problem is avoided by using Arena's turbine inlet air cooling system, one of its systems to cool this air stream. The refrigeration system also used in the production of electricity in a way where when the electricity is generating, there obviously will be produced a hot temperature outside of the system. refrigeration system is used to chill down to lower the temperature of outside of the electricity production system to increase the efficiency of the production of electricity. Okay, for the third one, the chemical and petrochemical. Temperature control is essential to obtain high efficiency in this transformation, and since this process include the removal of heat, refrigeration systems are necessary to obtain the outcome of operation, such as distillation, crystallization, and condensation. The same as the electricity production before, maintaining the temperature surrounding or around the chemical and petrochemical production process are very important so that the efficiency of the production is made sure to be at its best. Okay, the fourth one, pharmaceutical. A lot of industrial process entail biological or biochemical reaction that are limited to a few precise conditions that enable microbiological species to manufacture large amount of chemical substance. And for this reason, it is essential that pharmaceutical companies test their product in clean and germ-free environment. Okay, a lot of pharmacists or scientists needs to make sure that the temperature they are working in, whether in lab or anywhere, need to be a very specific range of number so that the microbiological or the microorganism they are working on will be keep at its best and alive. So for the last one, food and beverage. This is one of the company organization that required the temperature to be most important variable to guarantee the safety of the food during the preparation. We know that there are multiple type of food that needs to be kept and need to be kept in a low temperature surrounding so that it can be more sustainable. Okay, that is all from me. We will continue with my friend.
So for this part, I will explain about the analysis of the steady flow device and the performance of the steady flow device. Our group have decided to design an evaporator, and in this table it is the evaporator's dimension, which including the evaporation area, spacing of fin, thickness of the fin, tube spacing, row spacing, calculated pipe length, calculated fin quantity, and so on. So next I will talk about the performance of our evaporator. So to calculate the efficiency of the evaporator, we have used a software to calculate it. So we have taken into account the evaporating temperature, evaporating pressure, cooling capacity, and refrigerant flux. But due to a certain limitation of our knowledge, the result obtained might not be correct, as we did not use a precise method and tools to obtain and calculate the data used in this project. We also did not take into our consideration the heat from surrounding that can affect the performance of the evaporator.
So, in conclusion, steady flow mechanisms are made to permit the passage of fluid, gases, or liquids through them over time without causing appreciable variation in the fluid's density, temperature, or pressure at any one point in the device. There are three implications. First one is total efficiency and cost effectiveness of the systems. Reducing energy consumption can result in less greenhouse gas emissions, and lastly is small increases in the efficiency of pumps or turbines can result in significant cost savings. There are a few of future research directions of steady flow device. First one is computational fluid device (CFD), smart and adaptive designs, and lastly advanced material.